All right, last section of the, last section of the chapter. Everybody's up here? All right. Should have your notes out, ready to go. So we're going to do absolute value once more, but this time we're going to do it with inequalities. What am I talking about when I talk about inequalities? This is an equality. What's an inequality? Right, less than, greater than, or less than or equal to, greater than or equal to. So those are your inequalities. This is your what? Equality. Right, it's an equality. It's an equal sign. Okay. You're going to find, maybe, it shouldn't be too bad. So what we're going to do is we're going to do some graphing. All right, so we are going to graph. And it's not really an example, but they kind of start off with just the absolute value of x. See what it looks like, a regular, basic, everyday absolute value of x. Then we're going to do some things with it, okay? We're going to change some things around. But let's just do this. The absolute value of x, we're going to go greater than 3. So what I want to do is I want to understand, what does that mean? So that means what numbers can I put in for x to make it greater than 3? What's like an obvious choice? 4. 4 would be an obvious choice. Would you agree? Keep going. More than 3. 5, 6, 7, 8, and everything in between, right? So basically anything, what? Greater than 3. 3.1, 3.01, 3.000001 is greater than 3. We can include all that. You with me? But there's another set of numbers that we can include too, because remember, this is an absolute value. Yeah, what about negative 4? Or negative 3.1, and negative 3.01 and negative 3.0001, all right? So anything what? Less than 3, all right? Does it make sense? So it's kind of like we just finished doing. We put the plus and the minus for that, absolutely. No, because it's not or equal. This just says greater than. Yeah, but that's not the next number though, right? The next number would be super, super close to 3, but just not touching it. So how could we write this? Pretend this was the equal. We just finished doing a lesson with equals, right? So what did we say? We said that x could what? Be greater than 3, and x could be what? Greater than what? Negative 3, but, how should I say that? With the negative, well, it would be, but I'm trying to think of how we did it. Anyway, it's going to be less than 3. All right, that's what it's going to be. I'm sorry. Yes, correct. Negative 3. Okay. Well, because what we just talked about, right? What makes this work? Well, anything bigger than 3 makes it work, and anything less than negative 3 makes that work, right? Because negative 4 makes it work, because what's the absolute value of negative 4? It's 4. Is 4 greater than 3? Yeah. All right, so anything less. So if we were going to graph the thing, okay, I'm going to put a negative 3 right there and a positive 3 right there, then what would our graph look like? Its x is greater than 3, so circle, right, and then everything where? To the right. Okay? And it's not really bold. Let's make it look like this. That looks better. It does. Yeah. So that would be our graph, like that. We just discussed it. We had a big long talk about it. Because it's absolute value. Because pick a number that's less than negative 3. Pick a number that's less than negative 3. Give me a number that's less than negative 3. Give me a number. Negative 2 is bigger. Give me a number that's less than negative 3. Negative 4. Okay, you won't do it, I'll do it. Okay, it's negative 4. So look, what's the absolute value of negative 4? It's positive 4. Is positive 4 greater than 3? Yes, it is. So that means negative 4 is one of my possible solutions. I could keep going forever. Negative 5, negative 6, negative 7, that would make all that work. Anything smaller than, less than negative 3 is going to satisfy this. It's going to make it work. Go ahead. All right, so anything less than negative 3 makes that work. Anything what? Bigger than positive 3 makes that work. All right, or again, in the math world, what do we say? We don't just say makes it work. It's kind of an easy way to say it. We say it satisfies the equation. All right, that's what a lot of, or in this case, it's not an equation. It's a what? It's a inequality, right? Okay. All right, you with me on that? Okay. Here's how we, let's do another one. Let's push this up here. Watch, I'm going to do the absolute value of x, but instead of greater than 3, I want to do less than 3. By the way, I tell you what, before we get to that, let's do this. How would we write the answer here? Is this an and or an or? Did we do that in here? We did that in here, right? Okay, because in pre-calc we're doing that stuff too, and I'm trying to keep everything straight. Right, this would be an or. So what we would say is, what would our answer be? Our answer would basically just be this right here. Okay?
Wait, don't you need the or symbol?
Yeah, probably put the or symbol. All right, what's the or? Like a V? All right, you could put a V, or you could just write the word or. I'm fine with that. Okay? So that would be your answer. Okay? And that would be the graph. Because they're going to say, solve for x. This would be your solution for x. And they'll also say to graph it for a lot of these. All right, what about this? This is a little bit different. So let's think. What numbers for x is going to be less than 3? Well, give me a number. Give me a nice easy number. 2. Okay? So 2 would be less than 3, wouldn't it? 1 would be less than 3. Yeah? What about negatives? Negative 2. Right. Well, okay. So let's do the graph, and let's think about it. The graph can be very, very helpful to us. So that's why we're going to use it. All right. So let's think about, actually, yeah. So can you put a 4 in here? No. Can you put a 3 in there? No, you can't, because the absolute value of 3 is not less than 3. It's equal to it, okay? But that's going to be a place where we start, okay? Let's keep going down. Let's keep going lower. What about a 2? Yes, 2 is less than 3. Put a 1. Is 1 less than 3? I should say the absolute value of 1, which is 1. What about 0? Yep, that's less. What about negative 1? Yep. Okay, now, it's not because negative 1 is less than 3. It's because the absolute value of negative 1 is what? Is 1 is less than 3. What about negative 2? Yeah, what about negative 3? Nope. What about negative 4? Nope. So nothing past what? Negative 3. Okay? So here's how we're going to...
Wait, what do you mean negative 3 though?
Right. I said nothing past negative 3. Or 3. Or negative 3, correct. So that would be what kind of circle? Open here and open here. And everything where? In between. That's right. This would be in between. So what kind of function is this? This is a and function, okay? And so this is how we would write it. X could be any number in between negative 3 and positive 3. This is the best way to write it. Don't write x is greater than negative 3 and x is less than 3. Okay, that's too cumbersome. It's not a great way to write it. Here's what we do. X is in between. We talked about this, I think yesterday, didn't we? Put an x or less than. Yeah. And then what would we put here? Negative 3, positive 3. And that is your answer. Here's your graph. There's your answer. Okay? Because what does this say? This says, look, if I read it from right to left, this would say that x is greater than negative 3. So everything greater than 3. And it also has to be what? X has to be less than 3. That's why the and. It's got to satisfy both of them. Okay? The other one could just satisfy one or the other one. Okay? This has to satisfy both of them. It's intersection. Right? The and is an intersection. We got it? All right. Now, we're ready to do stuff. That wasn't an official example, but they kind of taught the lesson within an example. Right? This is technically the example. It's the same exact kind of thing. Almost don't even want to do this one. What time is it? 05. Okay. All right. So let's do this. It says solve and graph. Solve and graph. Here it is. It's basically the same thing. They change it up a little bit because they put greater than or equal to. Now, the greater than, let's go back and look at this. The greater than one is going to be the or. It goes in opposite directions, okay? Everybody see that? Because it keeps on going that way, keeps on going that way. It's greater, right? It's like that, all right? And then the less than is in between. It's in between the two, all right? So the greater than goes to the outsides, and the less than goes in between. If you can remember that, that really helps you with your graphs here. So let's take a look at this. This is greater than. Now it's greater than or equal to, but it is greater than. So we should be able to graph that pretty easy. And I would suggest that you graph it before you write down the solution. All right, I think it's easier just to look at it and see. So it's greater than and 2. So what numbers am I just going to put a 2 here? I'm also going to put a -2. All right, and what's this thing going to do? It's going to go opposite directions, isn't it? But what kind of circle do we have here? It's a closed circle. And this is going to go to the left. And this is going to be closed. And this is going to go to the right. And that's your graph. And so now, you got to write down your solution. So what's your solution? X is what? Well, let's go left and right. So x is less than what? Or equal to -2. What's the word in between? Or. X is greater than or equal to +2. So there's your graph, there's your answer. That's your solution. Okay? Let's do another one. Now we're getting a little trickier. Not a whole lot, but just a little bit. So again, it says solve and graph. Solve and graph. And as we're going to do, it's absolute value of 2x minus 7. So we got some stuff inside of here now. So we're going to have to do a little bit of work. There it is. Remember when we first did these? It was an equal sign before, right? It wasn't an inequality, but it was an equal sign. What did we do? We went 2x minus 7. We would go, if this was an equal sign, what would we do? 2x minus 7 equals 4, and then 2x minus 7 equals -4, okay? But since this is a inequality and it's less than, that means that x is going to be between two numbers, correct? We just don't know what those two numbers are. It's not going to be 4, right? We just got to figure it out because there's other stuff in here. Let me show you a nice way to write it. So this 2x minus 7 is going to be between, what do you think? 4 on this side and -4 on the other side. That's a good way to write it right there. All right, so we're going to take it from this to this. We could have written two separate ones, but it's a little bit more convenient. It's a little bit, I don't know what word I can use. Convenient, I guess, is good enough. Efficient, yeah, it's good to write it like this. Now, what we're going to do, I didn't show you this before because we separated both equations, but watch, show you a little trick. Actually, Max and I talked about this the other day, right? What you can do is you can get rid of the 7 right now. But now we don't just have a left side and a right side. We got a middle, a left, and a right. So whatever I do to this one, I got to do to both sides, all right? So if I add a 7 here, where else am I going to add a 7? Yeah, to the -4 and the 4, okay? That makes sense, doesn't it? All right, it's just, you see where it's more efficient, where you don't have to split them up into 2, you can kind of do it all at once here. Yeah. So let's see what we get there. So that cancels. I got a 2x here. I just added something, so I don't change my inequalities, correct? Add these up, what's that, 11? Add these up, and that's 3. Now what do you think I'd do? Divide both sides by 2. Well, not both sides, but yeah, kind of. The left side of the middle and the right side of the middle and the middle, right? So divide all 3 of these things by 2. And again, we divided by a +2. Do we change the inequality? No. All right, so that's my answer. 3/2 is less than x, which is less than 11/2. Now that's fine if you want to leave that as your answer, but we want to graph it, so we want to know generally where in the world is 3/2 and where in the world is 11/2. So let's write it as either a mixed number or a decimal. Okay, so what is this as a mixed number? It's 1.5. All right, so it's 1.5 is less than x, which is less than, yes, 5.5. Okay, so that's my solution So now we can graph it pretty easy. That means x is between. All right, so there's your number line. This right here, we'll just put 1.5. You don't have to put all the little things in there at this point, okay? I'm not worried about that. I just care about the endpoints. That's all I care about. And then this is going to be what, 5.5? And then we do what we've been doing. What kind of a, oops, I should have, that's open, and that's open, and it's what? It's less than, right? So it's everything in between, right? This means that x is between 1.5 and 5.5, and that's what that graph indicates right there. All right, yeah.
It's really relevant, but how do you get the projector to your laptop?
That was a slow question.
This thing right here, that
Yeah, but
cord,
I don't see the wire go anywhere.
it goes right through the wall right there, and it goes over to that.
Is that why there's always people in the ceiling? Like not
Sometimes.
here, but-
Well, mostly it's probably air conditioning. The reason they walk on the ceiling is usually because of the air
How
conditioning.
do they not fall through these?
Well, they don't walk through. There's metal beams above it.
Oh,
Yeah, you can't walk on these things. You'll go right through them because there's insulation on top of that stuff. All right. Let's go back. Let's make this white. All right. Let's do another one. Ready? Example 3. This isn't so hard, is it?
No.
All right. I'm not going to write solve and graph, but that's what we're going to do. Same kind of thing. Just a little bit more math. All right, what are you going to do first? Yeah, get rid of that 11 because I just want that absolute value by itself. So add 11 to both sides. All right, and so I got negative 4x plus 9 in absolute value greater than or equal to 15. Now, look, this is greater than. So this is what? And or? It's or. It goes this way, right? All right, so I'm going to put two separate ones. So I'm not going to put it in the middle like I did the last time. Why did I put it in the middle? Because it was less than. It was an and. That's right. See, it was less than something. All right, this time it's greater than. So I am going to separate it into two separate ones. So I'm going to go negative 4x plus 9 is greater than or equal to 15. And then I'm going to go, now if it's an inequality, what do we do to that inequality? Yeah, we change the inequality. And then it's going to be a negative 15. Okay? Because it's a negative. Basically, it's kind of like we made this negative and then we got rid of the negative and put it over here. And you do that by dividing or multiplying by a negative, which changes the direction of the inequality. Okay? And now you just solve. I'm going to not go through the whole math. You guys can do that. That's going to be less than or equal to negative 3 over 2. Why did that change from greater than to less than? Because you divided by this negative 4, right? And that changed that, okay? And this comes out to x is greater than or equal to 6. And that's your or, all right? And now to graph it.
My high school girls in 9th to 12th grade, dress checks need to be done by next Thursday. So you have between Monday the 23rd.
This is negative 1.5.
To bring your dresses in and get checked.
And this is 6.
Also another announcement.
It is or equal.
The following students do not have cards in, and if you don't arrive with them on Monday, or if you don't have them for Monday, then you'll need to stay home instead of coming to school.
Oh, that's a threat.
Quavis, Sophia Emery, Ezra T, Sage Lane, Caleb Emmanuel Nadenga, Emma Springer, Josiah Thompson.
All right, there it is right there.
Alexander, Nick Sophia. When Kelly, Joel Kennedy, David Lee.
Or goes that way. No, and goes in between like this. Or goes like that.
Hand touches.
It's an intersection. Remember, it's an intersection of the two. All right. Let's do another one. You ready? Example 4. So this one is a little bit weird. Yeah, this is ridiculous. I'm not going to put solve and graph. This is part A.
This is the whole middle school. You have to make them stay home. They're not doing it.
And these are 9th to 12th grade.
All right, this is less than, so it's a what? And or. It's an and. All right, so let's write it like this.
Is that one in middle school?
Oh, what just happened? Okay. All right, everybody up here. I know it's difficult to concentrate, but we can still do it. Look, see, I put the and right here. Now let's think about this. This is an and, so it should be an intersection. We want to find which points intersect with both of those things. So let's graph it, and then it'll appear right before your eyes. Watch. Oh, Mia Felice, we heard that. There's a 3. What's this going to look like? X is less than negative 3. I'll just keep it the same color because of time. X is what? Greater than 3. All right, everybody look at this. So remember, this is an and. Where do these two graphs intersect? What do they have in common? They got nothing in common. So what's my value for X then? It's nothing. There's no what? Solution. Since there's no intersection, there is no... Well, because this is an and. Because it's less than. You see it's less than, which means it's an and there's no intersection between these. Okay? If it was greater than, and it looked like this, it'd be okay. But if it's an and, which is less than, doesn't work. Let me just show you that. She actually got that right. Well, one of them's, you pronounce the N. In hers? In her name, you pronounce the N? All right, let's do this one. Ready? So X is greater. This will really see if you can concentrate. X is greater than. It's greater than, so it's this and or. It's or. And then X is less than 3. You see what we did? We made that the same. In this one, we changed the direction. We changed the sign. Let's graph it. Remember, this is an or. So let's do this. Let's do this. And we got a negative 3. We got a positive 3. All right, what does this say? X is greater than. I'm gonna do it like this. I'm gonna keep everything same color. It just takes too long. Watch. Everybody watching? Okay, so there's that one right there, isn't it? And X is less than 3. Let's do it up here. But what is this? It's not an and, though, is it? That's right. It's everything. It's everything. So this would be all real numbers. So all. Because think of it. It kind of makes sense. If I take the absolute value of any number at all in the world, it's always going to be bigger than negative 3, isn't it? Yeah, because it's going to be a positive. Any positive number is bigger than negative 3. Bell has it wrong. Have a seat. Have a seat. You're not seated. Okay, let's do one more. This is a little different. This says they're going to give you a graph, and you want to write an absolute value from that graph. This is the last thing, so just hang on a second. So they give you this. They give you the graph, and they're going to ask you actually that midpoint thing you did on the other homework. It's going to come in here as well. So it says write an absolute value. Here's what you're going to do. First thing you want to do is you want to find where the middle of this is. All right? They list it. I'm not going to because of time. But the first thing you do is find the midpoint. How do we find the midpoint? You add them up and divide by 2. That's negative 4 divided by 2, which is... Gio, hush. I'm trying to teach. have a little bit of sense. So this right here is negative 2. All right? And then what you want to do is find the distance between the endpoints. All right? That and that. So how far is it from there? It's negative 5 minus negative 2, which is what? It's 3. It's absolute value, right, of negative 3, which is 3. So how far is that? That's 3, and that's 3. This is how you set it up. Now watch and write it down, all right? So what you're going to do is you're going to go, so this right here, I should have colored it in, sorry. This is open, and this is everything shaded in between. There's your graph. Sorry about that. I should have written that earlier, okay? So there's your graph. What you're going to do is you're going to go x minus whatever the midpoint is. Everybody hear me? So it's x minus whatever the midpoint is. What's the midpoint? It's negative 2. So it's x minus negative 2. This goes in like this, so it's what? Less than or greater than? It's less than, because it's an and. Less than what? Less than that distance, 3. So we write it real nice, put that right there. That is how you write that as an inequality, okay? Your homework is 1 to 27 odds. It's not on your lesson plan thing, okay? No, because we went a day ahead this week, okay? So 1 to 27 odds. 1 to 27 odds. Okay, there it is right there. Page 48. Section 1.9. All right, there you go. Enjoy your weekend.